Right now, as you're watching this video, you're hurtling through space at over 500,000 miles. You can't feel it, you can't sense it, but every atom in your body, every breath you take, every thought crossing your mind is being dragged along by something so massive, so incomprehensibly powerful, that it defies every instinct we have about the nature of reality itself. 26,000 light years away, hidden behind veils of cosmic dust and gas, lurks a monster, not the kind from your childhood nightmares, but something far more terrifying, because it's absolutely real. This creature has no teeth, no claws, no roaring voice that echoes through the darkness. Instead, it devours light itself, bends the very fabric of space and time, and holds our entire galaxy in its gravitational grip, like a cosmic puppet master pulling invisible strings. This is Sagittarius A, and it's about to challenge everything you think you know about the universe. But here's what makes this story truly extraordinary. For most of human history, we had no idea this monster existed. We looked up at the night sky, saw the gentle sweep of the Milky Way across the darkness, and assumed we understood our cosmic neighborhood. We were wrong. Catastrophically, beautifully wrong. In this video, I'm going to take you on a journey to the very heart of our galaxy, where the laws of physics get twisted into impossible shapes, where time itself slows to a crawl, and where the boundary between science and science fiction dissolves entirely. We'll explore how scientists first detected this invisible beast, what happens when you get too close to its edge, and why understanding Sagittarius AI might be the key to understanding our place in an infinite cosmos that's stranger than we ever dared imagine. If you find comfort in these gentle explorations of space and science, I'd be grateful if you'd consider subscribing and giving this video a like. I'd love to know where you're watching from and what time it is for you. Feel free to drop your location and time in the comments below. By any chance, if your curiosity stretches beyond space and science, I would love to invite you all to visit and take a look at our new channel, Boring Money, a place where finance slows down and fortune gently drifts in. I've dropped a link in the video description. Do consider checking it out. But before we dive into the abyss, let me share something that will blow your mind. The monster we're about to meet isn't just massive, it weighs 4 million times more than our sun. That's not a typo. 4 million suns compressed into a region smaller than our solar system, and yet, despite its unimaginable mass, despite the fact that it's literally holding hundreds of billions of stars in orbital submission, this thing is so dark, so perfectly black, that we've only recently managed to take its photograph. The first image of Sagittarius A was released just 2 years ago, in 2022, and what it revealed changed astronomy forever. You see, this isn't just another space documentary about distant objects that have no impact on your daily life. This is personal. Right now, as you sit there, Sagittarius A is determining your fate. It's the reason our solar system exists in this particular corner of the galaxy. It's the reason the seasons change the way they do. It's even influencing the cosmic radiation that shapes evolution on Earth. We are, in the most literal sense, children of this monster. The story of how we discovered Sagittarius A reads like a cosmic detective novel, filled with brilliant minds chasing invisible clues across decades of painstaking observation. It begins in the 1930s, when a young engineer working for Bell Telephone Laboratories accidentally stumbled upon radio waves coming from the center of our galaxy. He had no idea what he was detecting, but he had just heard the first whisper from the monster's lair. For the next 50 years, astronomers would piece together fragments of evidence like investigators working a cold case. They couldn't see their target directly, because it's hidden behind thick clouds of interstellar dust that block visible light, but they could detect its influence. Stars near the galactic center were moving in ways that defied explanation, whipping around invisible gravitational anchors at speeds that should have torn them apart. Then came the breakthrough that changed everything. In the 1990s, 2 teams of astronomers began tracking individual stars orbiting near the galactic center with unprecedented precision. What they discovered was so extraordinary that it earned them the Nobel Prize in Physics. These stars weren't just moving fast, They were moving impossibly fast, completing orbits that took them closer to the galactic center than Pluto is to our Sun, reaching speeds of over 15 million miles per hour. One star in particular, designated S2, became the smoking gun that confirmed the monster's existence. S2 completes a full orbit around Sagittarius A every 16 years, and when it reaches its closest approach, something remarkable happens. The star's light gets stretched and distorted by the extreme gravity, confirming Einstein's predictions about how space and time behave near massive objects. This wasn't just astronomy anymore, this was physics at its absolute limit, where theory meets reality in the most extreme environment imaginable. But here's where the story gets truly mind-bending. The object these stars are orbiting, this 4 million solar mass monster, occupies a region of space no larger than about 20 million kilometers across. For comparison, that's smaller than the orbit of Mercury around our Sun. How do you pack that much mass into such a small space? There's only one answer that makes sense, and it's an answer that would have sounded like pure fantasy just a century ago. Sagittarius A is a supermassive black hole. Not just any black hole, but our black hole, the gravitational anchor point around which our entire galaxy rotates. And when I say entire galaxy, I mean every single one of the estimated 400 billion stars in the Milky Way, including our Sun, are ultimately dancing to the gravitational rhythm set by this cosmic monster. Now, before we go any further, I need to address something that might be making you uncomfortable right now. When most people hear black hole, they imagine a cosmic vacuum cleaner that's going to eventually suck up everything in the universe. That's not how black holes work. And Sagittarius A isn't going to destroy Earth or even our solar system. We're far too distant to be in any immediate danger. But that doesn't make it any less fascinating or important to understand. The real question isn't whether Sagittarius AH will destroy us. The real question is how this monster shaped the very existence of everything we know and love. You see, supermassive black holes like Sagittarius A aren't just cosmic curiosities sitting at the centers of galaxies. They're the architects of cosmic structure itself. They determine how galaxies form, how they evolve, and how they die. The relationship between Sagittarius A and the Milky Way is one of the most beautiful examples of cosmic symbiosis in the universe. The black hole's gravity holds the galaxy together, preventing it from flying apart as it rotates. But the galaxy, in turn, feeds the black hole, sending streams of gas and dust spiraling inward in a process that releases more energy than billions of nuclear bombs every single second. This feeding process creates one of the most spectacular light shows in the universe. As matter falls towards Sagittarius AA, it forms what astronomers call an accretion disk, a swirling maelstrom of superheated gas that glows brighter than entire star systems. The friction in this disk heats the gas to temperatures of millions of degrees, causing it to emit radiation across the entire electromagnetic spectrum from radio waves to X-rays. Sagittarius AI broadcasts its presence across the galaxy like a cosmic lighthouse. But here's what makes this truly extraordinary. The monster at the heart of our galaxy isn't always hungry. Sometimes it goes quiet for years, decades, even centuries, barely consuming any matter at all. Then, without warning, it roars back to life as a new stream of gas or an unlucky star wanders too close to its gravitational web. These feeding frenzies can increase the black hole's brightness by factors of hundreds or thousands, turning our normally quiet galactic center into a blazing beacon visible across intergalactic distances. The most recent major feeding event happened just a few years ago when astronomers watched a cloud of gas called G2 approach Sagittarius AI. For months, they held their breath, waiting to see if the cloud would survive its close encounter or be torn apart and devoured. The cloud survived, but barely, emerging as a stretched and distorted shadow of its former self. It was like watching a cosmic near-death experience in real time. This brings us to one of the most mind-bending aspects of studying Sagittarius AS. Because of the extreme gravity near the black hole, time itself behaves differently. If you could somehow survive near the event horizon, the boundary beyond which nothing can escape, you would watch the rest of the universe age rapidly, while your own time crawled forward at a snail's pace. This isn't science fiction. This is Einstein's general relativity playing out in the most extreme gravitational environment in our galaxy. The stars orbiting closest to Sagittarius A experience this time dilation effect, though to a much smaller degree. When S2 reaches its closest approach to the black hole, time passes about 200 seconds slower for every million seconds that pass for us here on Earth. It's a tiny effect, but it's measurable, and it confirms that our understanding of gravity and space-time is correct even in these extreme conditions. But perhaps the most remarkable thing about Sagittarius A isn't what it does to space and time, it's what it reveals about the history of our galaxy and our place within it. You see, supermassive black holes like this one don't just appear overnight. They grow slowly over billions of years, accumulating mass from their surroundings and occasionally merging with other black holes when galaxies collide. The monster at our galactic center has been growing for nearly as long as the Milky Way has existed. It was already ancient when our solar system formed 4.6 billion years ago. It watched the birth and death of countless generations of stars. It witnessed the formation of the heavy elements that would eventually become planets, life and consciousness capable of contemplating its existence. In a very real sense, Sagittarius A is the reason we exist. Without its gravitational influence, the Milky Way would never have developed the stable spiral structure that allowed regions like our local galactic neighborhood to remain relatively calm and safe for billions of years. The ordered rotation of our galaxy, the way spiral arms sweep through space, distributing heavy elements and triggering star formation, all of this cosmic choreography is orchestrated by the monster at our galactic center. But the story of Sagittarius A is far from over. In fact, we're living through one of the most exciting chapters in its history. Right now, astronomers around the world are watching and waiting for something extraordinary to happen. You see, our galactic neighbor, the Andromeda Galaxy, is heading straight for us at 250. In about 4.5 billion years, Andromeda will collide with the Milky Way in what astronomers poetically call the Andromeda Galactic Collision. When that happens, Sagittarius A won't be alone anymore. It will meet Andromeda's own supermassive black hole, an even larger monster weighing in at over 100 million solar masses. These two titans will spiral toward each other in a cosmic death dance that will reshape both galaxies entirely. But don't start planning your escape route just yet. The collision won't be like two cars crashing head-on. Space is so vast, and stars are so far apart, that most individual star systems, including our own, will likely survive the merger unscathed. What will change is the very structure of our cosmic home. The orderly spiral arms of both galaxies will be scrambled into a new formation, probably an elliptical galaxy that astronomers have already nicknamed Milkomeda. The real fireworks will happen when the two supermassive black holes finally merge. This event will release more energy and gravitational waves than all the stars in both galaxies combined, producing light. The ripples in space-time will be so powerful that they'll be detectable by gravitational wave observatories across the universe. It will be the loudest cosmic event in the local group of galaxies, a merger that announces the birth of a new galactic empire ruled by a single, even more massive black hole. This brings us to one of the most profound questions in modern astronomy. How did supermassive black holes like Sagittarius A get so big in the first place? You might think they started small and gradually grew by eating stars and gas over billions of years, but the math doesn't add up. Even if a black hole devoured matter at the maximum possible rate, it couldn't grow from stellar size to millions of solar masses in the time available since the Big Bang. The answer appears to be that supermassive black holes formed through a completely different process than their smaller cousins. Instead of being born from the collapse of individual stars, they may have emerged directly from the primordial universe itself. In the cosmic dark ages, before the first stars had even formed, massive clouds of hydrogen gas might have collapsed directly into black holes without ever becoming stars at all. These primordial monsters would have been the seeds of cosmic structure, the gravitational anchors around which the first galaxies began to form. They grew rapidly by consuming the abundant gas of the early universe, reaching enormous sizes while the cosmos was still young and dense. Sagittarius A isn't just the heart of our galaxy, it's potentially one of the oldest objects in the universe, a relic from an era when the fundamental forces of nature were still shaping the cosmic landscape. We're not just living in a galaxy that happens to have a black hole at its center, we're living in a galaxy that exists because of that black hole. The monster shaped the very environment that allowed stars like our Sun to form in stable, long-lived orbits. It created the conditions necessary for planetary systems to develop and persist for billions of years. But Sagittarius A's influence extends far beyond mere gravitational architecture. The black hole acts as a cosmic thermostat, regulating the temperature and density of gas throughout the galaxy. When it feeds actively, the energy it releases heats up the surrounding gas, preventing it from cooling and collapsing to form new stars. When it goes quiet, star formation can resume in nearby regions. This feedback mechanism means that Sagittarius A has been controlling the birth rate of stars in our galaxy for billions of years. It determines not just where stars form, but when they form and how many form at any given time. The monster doesn't just hold our galaxy together, it actively manages its evolution like a cosmic ecosystem engineer. Recent observations have revealed that this management system is incredibly sophisticated. Sagittarius A doesn't just randomly consume matter and release energy, it responds to the conditions in its environment, becoming more active when there's abundant fuel available and going dormant when resources are scarce. It's almost as if the black hole is alive, breathing in rhythm with the galaxy around it. The breathing pattern of our galactic monster follows cycles that last millions of years. During active phases, Sagittarius A blazes with the light of billions of suns, heating gas clouds throughout the inner galaxy and launching powerful jets of particles that extend thousands of light-years into space. These jets carve enormous bubbles in the galactic gas, creating structures so large they dwarf entire star-forming regions. During quiet phases, the monster becomes almost invisible, detectable only through the orbital dance of nearby stars and the occasional flicker of radiation from small amounts of infalling matter. These dormant periods allow gas to cool and accumulate near the galactic center, setting the stage for the next feeding frenzy when conditions are right. We're living through one of these quiet periods right now. Sagittarius AS is consuming matter at a rate far below its theoretical maximum, barely glowing with the energy equivalent of a few million suns. But astronomers know this tranquility won't last forever. The monster is simply waiting for its next meal, and when that meal arrives, our entire galaxy will light up like a cosmic Christmas tree. The most likely trigger for the next major feeding event will be the disruption of gas clouds, or a star that wanders too close to the point of no return under the gravitational influence of nearby stars. When that happens, we'll witness one of the most spectacular shows in the universe, broadcast live from the heart of our own galaxy. But here's what makes studying Sagittarius A so challenging and so fascinating. The monster is hidden behind layers of cosmic dust that block most wavelengths of light. For decades, astronomers could only glimpse it indirectly, like detectives trying to understand a crime scene through shadows on the wall. They had to develop entirely new ways to peer through the cosmic fog. The breakthrough came with new ways of seeing, using radio waves, infrared radiation, and X-rays. The development of adaptive optics and space-based telescopes that could compensate for atmospheric distortion and cut through interstellar dust changed everything. Suddenly, astronomers could track individual stars as they orbited the invisible monster, mapping their paths with precision that would have been unimaginable just a few decades earlier. The most remarkable of these stellar dancers is a star called S62, which holds the record for the closest approach to Sagittarius A ever observed. At its nearest point, S62 comes within just 120 times the distance from Earth to the Sun, traveling at nearly 5% the speed of light. For comparison, that's like a race car completing a lap around Earth in less than 7 seconds. At such extreme speeds, and in such powerful gravitational fields, the very nature of reality becomes fluid. Space contracts, time dilates, and the familiar laws of physics push into regimes where quantum mechanics and general relativity must somehow work together to describe what's happening. CES-62 and other close-orbiting stars have become natural laboratories for testing our understanding of fundamental physics in conditions that can never be replicated on Earth. Each orbit of these stellar test particles provides new data about the nature of gravity, the structure of space-time, and the behavior of matter in extreme environments. They're writing the equations of physics in their orbital paths, creating a cosmic textbook that astronomers are only just learning to read. But perhaps the most extraordinary aspect of Sagittarius A isn't its gravitational influence or its role in galactic evolution. It's the fact that this monster, this 4 million solar mass beast that holds our entire galaxy in its grip, is actually quite small compared to the supermassive black holes found in other galaxies. In the cosmic hierarchy of monsters, our Sagittarius AI is practically a lightweight. The largest supermassive black holes in the universe dwarf our galactic monster by factors of thousands. There's a behemoth called Tunnan 6118 that weighs in at over 60 billion solar masses. That's 15,000 times more massive than Sagittarius A. If our monster is a great white shark, then Tunnan 6118 is Godzilla with a physics degree and a bad attitude. But here's the beautiful irony. The fact that Sagittarius A Ace is relatively small might be exactly why we exist. You see, there's a delicate balance at play here. If our galactic monster were too small, it wouldn't be able to hold the Milky Way together. The galaxy would be a chaotic, unstable mess of stars flying in random directions. But if it were too large, it would be so active, so violently energetic, that it would sterilize vast regions of the galaxy with deadly radiation. Sagittarius A sits right in the cosmic Goldilocks zone. Not too big, not too small, but just right for creating the stable, long-lived galaxy that allowed complex chemistry to develop over billions of years. It's as if the universe fine-tuned our monster specifically to create conditions suitable for life. This realization has led some scientists to propose what they call the galactic habitable zone theory. Just as planets need to orbit at the right distance from their star to support liquid water, perhaps life needs to exist at the right distance from the galactic center to avoid the sterilizing effects of supermassive black hole activity. We're sitting pretty in the galactic suburbs, far enough from the monster to be safe, but close enough to benefit from its gravitational architecture. But safety is relative in a universe full of monsters. While Sagittarius A isn't going to destroy us tomorrow, its very existence poses questions about the ultimate fate of everything we hold dear. Black holes, you see, are among the most patient predators in the universe. They don't need to hunt, they simply wait, and eventually, everything comes to them. Over cosmic time scales that dwarf human imagination, Sagittarius A will continue to grow. It will consume gas clouds, devour unlucky stars, and merge with other black holes. Each meal makes it slightly more massive, slightly more powerful, slightly more capable of influencing the galaxy around it. In 1 trillion years, our monster might be 10 times its current size. In 100 trillion years, it might be the only thing left in our galaxy besides the cold, dead remnants of burned-out stars. This brings us to one of the most haunting predictions in all of astrophysics. The universe is expanding, and that expansion is accelerating, driven by the mysterious force we call dark energy. As space itself stretches, galaxies are being carried apart at ever-increasing speeds. Eventually, billions of years from now, distant galaxies will recede beyond our cosmic horizon, disappearing from view as if they never existed. The Milky Way will become an island universe, alone in an ocean of expanding darkness, and at the heart of that island will sit Sagittarius A us, grown enormous by eons of feeding. The last active object in a galaxy of ghosts, the final lighthouse in our cosmic neighborhood, the last source of energy in a region of space growing cold and empty. But even monsters aren't immortal. Stephen Hawking discovered that black holes emit radiation, slowly evaporating over timescales, so vast they make the current age of the universe seem like a fleeting moment. Sagittarius A will eventually fade away, taking with it the last traces of the galaxy it once ruled. In the end, even the monster will become a memory, a whisper of gravity in an empty cosmos. Yet, there's something profoundly beautiful about this cosmic story. We exist during the brief, shining moment when the universe is young and full of energy, when monsters like Sagittarius AI are actively shaping galactic architecture, when stars are being born, planets are forming, and life is emerging on countless worlds across the cosmos. We're witnessing the universe in its prime, and our monster is part of that magnificent spectacle. The story becomes even more remarkable when you consider how we discovered all of this. For most of human history, the monster at our galactic center was completely invisible to us. Our ancestors looked up at the night sky and saw the Milky Way as a gentle river of light, having no idea that it was actually a vast spiral of hundreds of billions of stars, held together by an invisible gravitational anchor. The first hint that something massive lurked at the galactic center came from radio astronomy in the 1930s, but it took decades to piece together what those radio signals meant. Scientists had to invent entirely new ways of seeing, develop technologies that didn't exist when the mystery first presented itself. They had to learn to read the language of gravity itself, interpreting the orbital dances of distant stars like cosmic archaeologists deciphering ancient hieroglyphs. The breakthrough moment came when astronomers realized they could use the stars themselves as probes, natural test particles that revealed the invisible monster's presence through their gravitational ballet. It was like solving a murder case where the only evidence was the way shadows moved across a wall, requiring decades of patient observation to understand what was casting those shadows. The development of adaptive optics technology in the 1990s finally allowed astronomers to track individual stars near the galactic center with unprecedented precision. Suddenly, they could watch stellar orbits unfold in real time, creating time-lapse movies of gravity in action that would have seemed like pure magic to earlier generations of scientists. One of the most extraordinary aspects of this detective story is how it required international collaboration on a scale rarely seen in science. The monster is visible from both hemispheres of Earth, and different telescopes around the world had to work together to maintain continuous observations. Radio telescopes in Puerto Rico, optical telescopes in Chile, X-ray satellites in orbit, infrared observatories on mountaintops in Hawaii, all contributed pieces to the puzzle. The Event Horizon Telescope project, which finally captured the first direct image of Sagittarius AS in 2022, involved telescopes on 6 continents working in perfect synchronization. They had to account for Earth's rotation, atmospheric conditions, equipment failures, and even political tensions that sometimes made international collaboration challenging. The image they produced wasn't just a scientific triumph, it was a testament to human cooperation in the face of cosmic mystery. That first image revealed something both familiar and alien. Sagittarius AX looks remarkably similar to M87, the supermassive black hole in a distant galaxy that was photographed 3 years earlier. Both show the same characteristic ring of glowing matter surrounding a dark central region, the same asymmetries caused by the extreme rotation of matter in the accretion disk. But there were subtle differences that revealed Sagittarius A's unique personality. Our monster is much more variable than M87, flickering and changing brightness on timescales of minutes rather than days. It's like comparing a steady campfire to a strobe light. This variability makes Sagittarius A much more challenging to photograph, requiring sophisticated computer algorithms to piece together a coherent image from rapidly changing data. The flickering nature of our monster tells us something important about how matter behaves in the extreme environment near a black hole's event horizon. Gas doesn't fall in smoothly and steadily. Instead, it forms hotspots and magnetic field lines that twist and reconnect in chaotic patterns, creating sudden bursts of radiation that light up different parts of the accretion disk unpredictably. These magnetic field interactions are so violent that they can accelerate particles to nearly the speed of light, creating jets of matter that shoot outward from the black hole at incredible velocities. Sagittarius A's jets aren't as prominent as those from more active supermassive black holes, but they're still powerful enough to carve bubbles in the galactic gas that extend thousands of light-years from the monster's lair. Recent observations have revealed that these bubbles, called Fermi bubbles after the space telescope that discovered them, are filled with high-energy particles and magnetic fields that affect the entire galactic environment. The bubbles are like cosmic lungs, breathing energy and matter in and out of the galactic center in cycles that last millions of years. The discovery of the Fermi bubbles was one of those moments in science when a new observation completely changes your perspective on something you thought you understood. Suddenly, Sagittarius AC wasn't just an ephemeral anchor sitting passively at the galactic center, it was an active participant in galactic ecology, pumping energy throughout the Milky Way and influencing processes happening thousands of light years away. This revelation has forced astronomers to reconsider the role of supermassive black holes in cosmic evolution. They're not just endpoints of gravitational collapse, they're cosmic engines that regulate star formation, distribute heavy elements, and shape the large-scale structure of the universe. The monster at our galactic center isn't just holding our galaxy together, it's actively managing its development like a cosmic gardener tending to a billion-star ecosystem. The management system is incredibly sophisticated. When Sagittarius A feeds actively, it releases energy that heats up gas clouds throughout the inner galaxy, preventing them from cooling and collapsing to form new stars. This creates a negative feedback loop that regulates star formation rates and prevents the galaxy from burning through its gas supply too quickly. But the system also includes positive feedback mechanisms. The energy released by the monster can trigger star formation in certain regions. By compressing gas clouds or by enriching them with heavy elements ejected from the black hole's vicinity, the result is a complex dance of creation and destruction choreographed by gravity over billions of years. Understanding this dance has become one of the holy grails of modern astrophysics. Scientists are using supercomputers to simulate the interaction between supermassive black holes and their host galaxies, trying to reproduce the observed properties of real galaxies like our own. These simulations require some of the most powerful computers on Earth, modeling the behavior of millions of particles over billions of years of cosmic evolution. The simulations reveal that the relationship between Sagittarius AI and the Milky Way is far more intimate than anyone initially suspected. The monster doesn't just influence its immediate surroundings, its gravitational effects ripple outward through the entire galactic disk, affecting the orbits of stars tens of thousands of light years away. Every star in our galaxy, including our Sun, carries the subtle signature of the monster's gravitational influence in its orbital motion. This means that Sagittarius A has been shaping our cosmic neighborhood for the entire 4.6 billion year history of our solar system. The monster's gravity helps determine the particular orbit our Sun follows around the galactic center, which in turn influence the rate at which our solar system encounters molecular clouds, stellar nurseries, and other galactic hazards that could affect life on Earth. We're not just passengers in a galaxy that happens to contain a supermassive black hole. We're products of that black hole's influence, shaped by billions of years of cosmic evolution orchestrated by the monster at our galactic center. The calcium in our bones, the iron in our blood, the oxygen we breathe, all of these elements were processed through stellar life cycles that were themselves influenced by Sagittarius A's regulation of galactic star formation. In a very real sense, we are children of the monster forged in the cosmic furnace that it has been tending for eons. But this intimate connection raises a question that keeps cosmologists awake at night. If Sagittarius AA has such profound influence over our galaxy's development, what happens when it changes its behavior? What happens when the monster wakes up from its current slumber and begins feeding again? The answer might be written in the geological record of our own planet. Some scientists have proposed that past feeding frenzies of Sagittarius AC could have influenced Earth's climate, and even the evolution of life itself. When the monster becomes active, it doesn't just heat up gas in the galactic center. It launches high-energy particles and radiation that can travel thousands of light years, potentially affecting the cosmic ray environment throughout the galaxy. Cosmic rays are like invisible bullets of energy that constantly bombard Earth from space. Our planet's magnetic field and atmosphere protect us from most of this radiation, but changes in the cosmic ray flux could still influence cloud formation, climate patterns, and even mutation rates in living organisms. It's possible that some of the major evolutionary transitions in Earth's history coincide with periods of increased activity from our galactic monster. This connection between the monster at our galactic center and life on Earth represents one of the most profound examples of cosmic ecology ever discovered. We're not isolated on our small blue planet, insulated from the vast forces operating in deep space. We're part of an interconnected system that spans the entire galaxy, where events happening 26,000 light-years away can influence the development of consciousness on a rocky world orbiting an ordinary star. But the monster's influence extends beyond our own galaxy. Sagittarius A/S is part of a cosmic hierarchy of supermassive black holes that stretches across the observable universe. These monsters communicate with each other through gravitational waves, ripples in space-time that carry information about their masses, spins and orbital dynamics across intergalactic distances. When two supermassive black holes merge, they create gravitational wave signatures so powerful that they can be detected by observatories on Earth, even when the merger happens billions of light-years away. These cosmic collisions are like notes in a symphony of space-time, each one telling us something about the population of monsters scattered throughout the universe. The gravitational wave detectors that first confirmed Einstein's predictions about ripples in space-time have opened an entirely new window into the monster-filled cosmos. We're now able to eavesdrop on the conversations between black holes, listening to their final moments as they spiral toward each other in cosmic death dances that release more energy than entire galaxies produce in light. These observations have revealed that supermassive black holes are far more common than anyone expected. Nearly every large galaxy appears to harbor a monster at its center, and the masses of these black holes are tightly correlated with the properties of their host galaxies. It's as if the monsters and their galaxies grew up together, each shaping the other's development through billions of years of cosmic evolution. This correlation, known as the black hole galaxy mass relationship, suggests that the formation of supermassive black holes and the formation of galaxies are intimately connected processes. The monsters aren't just passengers riding along in pre-existing galaxies. They're fundamental components of galactic architecture, as essential to a galaxy's structure as the nucleus is to an atom. The discovery of this relationship has revolutionized our understanding of how the universe evolved from the smooth, nearly featureless state revealed by the cosmic microwave background to the rich tapestry of galaxies, stars, and planets we see today. The monsters weren't just observers of cosmic evolution, they were active participants, architects of the large-scale structure that defines our universe. But here's where the story takes an even more remarkable turn. The monster at our galactic center might not be unique in its current quiet behavior. Observations of other galaxies suggest that supermassive black holes go through cycles of activity and dormancy that can last millions or even billions of years. Some galaxies show evidence of ancient feeding frenzies that ended long ago, leaving behind only the fossilized remains of massive outflows and shockwaves in the galactic gas. Other galaxies are caught in the act of feeding their monsters, their central regions blazing with the light of matter falling into supermassive black holes at prodigious rates. These active galactic nuclei can outshine the combined light of all the stars in their host galaxies, creating beacons visible across billions of light-years of space. The most extreme examples are called quasars, supermassive black holes feeding so voraciously that they become the brightest objects in the universe. A single quasar can emit more energy than 1,000 galaxies powered entirely by matter falling into a region no larger than our solar system. These cosmic lighthouses mark the locations of the most massive monsters in the universe, feeding frenzies so intense they can be seen from the very edge of the observable cosmos. When astronomers look at quasars, they're seeing what Sagittarius A might have looked like billions of years ago. During the early epochs of galactic formation, when gas was abundant and feeding rates were much higher, our monster was probably much more active in its youth, blazing across the cosmos like a cosmic searchlight during the wild early days of the Milky Way's development. The transition from active quasar to quiet supermassive black hole represents one of the most dramatic transformations in cosmic evolution. As galaxies mature and exhaust their gas supplies, their central monsters gradually starve, fading from brilliant beacons to nearly invisible gravitational anchors. Sagittarius AP has undergone this transition, settling into the quiet retirement of a well-fed predator in a galaxy that has reached middle age. But retirement doesn't mean death. The monster is simply waiting, patient as only a black hole can be, for the next opportunity to feed. That opportunity could come from several sources. Gas clouds occasionally wander too close to the galactic center, providing fuel for brief periods of increased activity. Unlucky stars sometimes have their orbits perturbed, sending them on collision courses with the monster's accretion disk. More dramatically, the eventual collision with Andromeda will provide Sagittarius A with a feast unlike anything it has experienced in billions of years. The gravitational chaos of the galactic merger will send streams of gas spiraling toward both supermassive black holes, triggering feeding frenzies that will light up both galaxies like cosmic fireworks displays. The merger will also bring our monster face to face with its counterpart from Andromeda, setting up a gravitational dance that will last millions of years as the two black holes spiral toward each other. This cosmic ballet will be one of the most spectacular events in the local group of galaxies, a slow-motion collision between titans that will reshape the gravitational landscape of our cosmic neighborhood. When the two monsters finally merge, they'll create gravitational waves so powerful that they'll be detectable by observatories throughout the local group and beyond. The merger will birth a new, even more massive supermassive black hole, a cosmic emperor ruling over the combined remnants of two ancient galactic civilizations. But that merger is still billions of years in the future. For now, Sagittarius A Ace continues its patient watch over our galaxy, maintaining the gravitational order that has allowed complex chemistry and biology to flourish in places like our solar system. The monster is both our creator and our ultimate destiny, the force that shaped our cosmic environment and the entity that will eventually inherit whatever remains of our galactic civilization. This duality, creator and destroyer, architect and entropy, captures something essential about the role of supermassive black holes in cosmic evolution. They're not simply endpoints of gravitational collapse, cosmic vacuum cleaners mindlessly consuming everything in their path. They're sophisticated regulatory systems that have been managing galactic ecosystems for billions of years, creating the conditions necessary for stars, planets, and life, while simultaneously representing the ultimate fate of all matter in the universe. The monster at our galactic center embodies this cosmic paradox. It's the reason we exist, and the guarantee that our existence is temporary. It created the stable galactic environment that allowed our sun to burn steadily for billions of years, but it will also be here long after our sun has exhausted its nuclear fuel and faded to a cold white dwarf. Understanding this paradox requires us to think about time on scales that dwarf human experience. The monster operates on cosmic time scales, where millions of years pass like seconds, where the rise and fall of entire civilizations are brief flickers in an eternal gravitational dance. From its perspective, the entire history of life on Earth is just a momentary burst of complexity in an otherwise quiet corner of the galaxy. Yet, from our perspective, trapped as we are in the narrow slice of cosmic history, when intelligence has emerged and begun to contemplate its own existence, the monster represents both mystery and opportunity. Every observation of Sagittarius A teaches us something new about the fundamental nature of gravity, space-time, and the large-scale structure of the universe. The monster is our local laboratory for testing the most extreme predictions of Einstein's theory of general relativity. The environment near its event horizon represents conditions so extreme that they push our understanding of physics to its absolute limits. Quantum mechanics and general relativity, the two pillars of modern physics, must somehow work together to describe what happens in the monster's domain. But we don't yet have a complete theory of quantum gravity to guide us. This gap in our understanding makes Sagittarius A more than just an astronomical object. It's a cosmic Rosetta Stone, a natural experiment that might help us decode the deepest laws of physics. The monster is writing the equations of reality in the orbital paths of nearby stars, in the behavior of infalling matter, in the structure of space-time itself. Every new observation brings us closer to understanding these equations, but they also reveal how much we still don't know. The monster keeps its secrets well, hiding them behind event horizons where information cannot escape. In regions where the very concepts of space and time break down according to our current theories. But perhaps the most remarkable secret that Sagittarius A has revealed is the interconnectedness of cosmic evolution. The monster has shown us that galaxies, stars, and planets don't evolve in isolation. They're part of a vast interconnected web of gravitational relationships that spans the entire observable universe. The calcium in our bones was processed through stellar nucleosynthesis rates, regulated by supermassive black holes. The iron in our blood was scattered by supernovae, whose timing was influenced by galactic-scale feedback processes, orchestrated by monsters like Sagittarius A. Even the water we drink carries the chemical signature of cosmic evolution, guided by supermassive black holes over billions of years. We are not separate from the monster at our galactic center. We are part of its extended family, products of the cosmic ecosystem it has been managing since before Earth existed. In studying Sagittarius A, we're not just learning about a distant astronomical object. We're discovering our own cosmic genealogy, tracing our origins back to the fundamental forces that have been shaping the universe since its earliest moments. This realization transforms how we think about our place in the cosmos. We're not accidental byproducts of random processes operating in an indifferent universe. We're integral components of cosmic evolution, temporary arrangements of matter and energy that have achieved the remarkable ability to contemplate the very forces that created us. The monster at our galactic center has been waiting patiently for billions of years for moments like this, when the universe becomes aware of itself through the emergence of conscious beings capable of understanding their cosmic heritage. In a very real sense, we are the monster's way of studying itself, its method of achieving self-awareness through the evolution of intelligence in the galaxies it governs. This perspective doesn't diminish our significance. If anything, it magnifies it. We represent a remarkable achievement in cosmic evolution, the emergence of complexity and consciousness from the gravitational architecture, orchestrated by supermassive black holes. We are the universe's most sophisticated attempt at self-understanding, and our studies of monsters like Sagittarius A are cosmic evolution, becoming conscious of its own processes. The story of how we discovered the monster at our galactic center is really the story of how the universe learned to see itself. Through our telescopes and theories, through our patient observations and bold hypotheses, cosmic evolution has developed eyes and minds capable of perceiving its own deepest structures. And the story is far from over. New telescopes coming online in the next decade will peer deeper into the monster's domain than ever before, revealing details of the environment near the event horizon that we can barely imagine. Space-based gravitational wave detectors will listen for the whispers of space-time as matter falls into black holes throughout the universe. Advanced computer simulations will model the behavior of matter and energy in gravitational fields, so extreme they defy human intuition. Each new discovery will add another chapter to the remarkable story of Sagittarius A and its role in cosmic evolution. But perhaps the most important chapter is the one being written right now, as conscious beings scattered across a small planet take their first tentative steps toward understanding the monster that has shaped their existence since before they were born. We stand at the threshold of a new era in our relationship with the cosmos, an age when we're beginning to understand our true cosmic heritage and our intimate connection to the forces that govern reality itself. The monster at the heart of our galaxy is no longer just a distant curiosity. It's family, the ancient architect of the cosmic environment that made our existence possible. And in that recognition, in that moment of cosmic understanding, perhaps we catch a glimpse of what the universe has been trying to achieve through billions of years of evolution, the emergence of consciousness capable of comprehending the magnificent, terrifying, beautiful monster that has been guiding our destiny from the very beginning. The relationship between time and space near Sagittarius A reveals one of the universe's most profound mysteries. As you get closer to the monster, time doesn't just slow down, it becomes elastic, stretching and compressing in ways that challenge every assumption we have about the nature of reality itself. A clock placed near the event horizon would tick at a different rate than one here on Earth, not because of mechanical failure, but because time itself flows differently in the monster's gravitational embrace. This isn't theoretical physics anymore, it's measurable reality. The stars orbiting closest to Sagittarius A are natural timepieces, their light carrying the signature of temporal distortion across 26,000 light-years of space. When astronomers analyze the spectrum of light from these stellar test particles, they can detect the subtle ways that gravity warps the passage of time itself. The implications are staggering. If you could somehow survive a journey to the monster's edge and return to Earth, you would find that centuries had passed while you experienced only hours. The people you left behind would be long dead, their civilizations risen and fallen, while you remained virtually unchanged by the passage of what we call time. The monster doesn't just bend space, it bends the very flow of existence itself. But here's what makes this truly mind-bending. The distortion of time, near Sagittarius AA, means that the monster exists in a different temporal reference frame than the rest of our galaxy. Events that seem to unfold over millions of years, from our perspective, might appear to happen much more rapidly to an observer near the black hole. The monster experiences cosmic evolution at a different pace than the stars it governs. This temporal complexity adds layers to our understanding of how supermassive black holes interact with their galactic environments. The feedback loops that regulate star formation don't just operate across vast distances of space, they operate across different flows of time, creating a four-dimensional dance of matter, energy, and temporal distortion that we're only beginning to comprehend. The monster's influence on time extends far beyond its immediate vicinity. The gravitational waves produced by matter falling into Sagittarius A carry information about temporal distortion across the galaxy. These ripples in space-time are like temporal messengers, spreading the monster's influence through both space and time simultaneously. Recent theoretical work suggests that the monster might even influence the arrow of time itself. In regions of extreme gravitational distortion, the usual relationship between cause and effect becomes blurred. Events that we would normally consider sequential might become simultaneous, or even reversed, from certain perspectives. The monster creates pockets of space-time where the familiar logic of temporal sequence breaks down entirely. This breakdown of temporal logic has profound implications for our understanding of information and consciousness. If time flows differently near the monster, then information processing itself must operate according to different rules. Any form of intelligence that evolved in the monster's immediate vicinity would experience reality in ways that are literally inconceivable to minds like ours, shaped by billions of years of evolution in regions where time flows steadily forward. The monster forces us to confront the possibility that consciousness itself might be a temporal phenomenon, dependent on the particular flow of time that exists in our corner of the galaxy. We think of awareness as something that exists in the present moment, but near Sagittarius A, the very concept of a present moment becomes meaningless. Past, present, and future blend into a temporal soup where linear thinking cannot survive. This temporal complexity reveals why the monster has remained mysterious for so long. We've been trying to understand it using concepts of time and causality that simply don't apply in its domain. It's like trying to understand music by looking at a single note, or trying to comprehend a movie by examining one frame. The monster operates on scales of space and time that transcend our ordinary experience. But the monster's mysteries extend beyond the warping of space-time. Deep within its accretion disk, matter behaves in ways that challenge our understanding of physics itself. As gas and dust spiral toward the event horizon, they reach temperatures of billions of degrees, hot enough to strip electrons from atomic nuclei and create a plasma so energetic that it glows across the entire electromagnetic spectrum. In this hellish environment, magnetic fields become twisted into complex geometries that would be impossible anywhere else in the universe. These magnetic structures can store and release energy in sudden, violent bursts that launch jets of particles at nearly the speed of light. The monster becomes a cosmic particle accelerator, creating energies that dwarf anything we can produce on Earth. The particles accelerated by Sagittarius A don't just disappear into space. They carry information about the monster's feeding habits across vast distances, creating a cosmic telegraph system that broadcasts the black hole's activity throughout the galaxy. When the monster feeds, radio telescopes on Earth can detect the afterglow of its meal within hours or days. This real-time connection between Earth and the galactic center represents one of the most remarkable achievements in modern astronomy. We can now monitor the monster's behavior almost as it happens, watching gas clouds get shredded and consumed in processes that release more energy than entire star systems produce over their lifetimes. The monitoring has revealed that Sagittarius AS is surprisingly finicky about its food. The monster doesn't consume everything that comes near it. Instead, it seems to sample different types of matter, sometimes rejecting gas clouds that appear perfectly suitable for consumption. This selective feeding behavior suggests that the physics of black hole accretion is far more complex than anyone initially suspected. The monster's dietary preferences might be related to the magnetic properties of infalling matter. Gas clouds with certain magnetic field orientations might be easier to digest than others. Or perhaps the monster's feeding is influenced by the rotation rate of the accretion disk, which could create resonances that either enhance or inhibit the infall of matter. Understanding these feeding mechanisms has become one of the hottest topics in black hole physics. Scientists are using supercomputers to simulate the complex magnetohydrodynamics of matter falling into supermassive black holes, trying to reproduce the observed feeding patterns of monsters like Sagittarius A. The simulations reveal that the environment around a supermassive black hole is far from the simple picture of matter spiraling smoothly inward that was once imagined. Instead, it's a chaotic maelstrom of magnetic fields, shockwaves, and turbulent flows that create conditions unlike anything else in the universe. Matter doesn't fall straight into the monster. It gets caught up in magnetic tornadoes that can persist for months or years before finally delivering their contents to the event horizon. These magnetic tornadoes are visible in radio observations as bright spots that orbit around the monster at incredible speeds. Astronomers can track these spots as they spiral inward, watching matter take its final journey into the abyss. It's like having a front row seat to the most extreme gravitational show in the galaxy.